Hi everyone, welcome back. I'm just gonna show you in this short video. I'm not going to run a 50-minute long video. This one is going to be fairly short, but I'm going to show you how I turn this lamp that I found in a bin while I was working installing cameras a couple of years ago. I'm going to show you how I turn that into this. So I found this lamp in a bin, and I thought I just plugged that into a PowerPoint. It came up, it worked perfectly. So I thought I'm just gonna take it home and I'm gonna I'll try to fix it. I'll try to do something with this lamp. And well, it occurred to me that I could 3D print a lot of things, a lot of small pieces, and put them all together to make this kind of base for this model. So I'm going to show you what application I used. I'm going to show you just the basics. I'm not going to go deep dive into this video on how to use OnShape, because I'm not an expert on OnShape. I just started to use this application probably 1 year ago. I'm not an expert on graphic design, or I'm not an expert on engineering stuff. I just went through what I've learned and really basic: create forms, make holes, and send it to print. So I'm going to show you how I did that. And also I'm going to tell you things that I kept in mind so that the holes that I used on the 3D printing models they fit properly. Now you have to keep in mind that on your printer, if you are using a different printer, I am using the Elegoo Neptune 3, the standard model. It has some tolerances, so you need to know your printer. You really need to dial in and test some bits of the printer, as in, I'm gonna show you, but for example, the holes and the pins. When you make a hole that is, I don't know, 5 millimeters diameter, and you create a pin that is 4.9 on the printer, it could be 5 on the hole, but the pin could be 5 or 4.95. So it'll be super snug and it won't fit at all. So in my case, on my printer, I always use 0.4 or 0.3 distances, meaning if the hole of a pin of an insert is 5 millimeters, I will use the pin. The pin will be 4.6 4.5 millimeters on diameter. So it'll give me 0.25 on the top and 0.25 on the bottom. And that will give me a fairly good space to fit them in, and it won't fail. Sometimes it does, but anyways, you just can sand the pin around, or make a small sand in, like sanding inside the hole where the pin is going into, and that will make it work. So let me show you this. This is OnShape, where I designed everything, like the whole model. However, the lamp itself, the bulb, it's 1.2 meters long, and this is just like, I don't know, 600 mil long, because what I did was I printed two pieces of this one, one of this one, two of the guitars, two of these ones. Well, this is the base, this is the top, and I had to modify the model with the printings, and I'm going to show you why. There were a couple of failed printers and printing, sorry, and I'm going to show you where it failed and why they failed. And this is the base of the lamp, because inside this box you will have, I'm just gonna hide this part. This part is this one. Now again, I'm not an expert on OnShape, so this is a huge mess of sketches and extrusions and stuff. Don't judge me, please. So I'm just gonna hide these, and this is the base where I'll show you a photo as well, where all the components are sitting. So there is a huge, well, not a huge, but small transformer and a couple of starters and that stuff. So things that I kept in mind to do this was, so on the top here, on this area, you have the small, I don't know how to call the connector, where you put the bulb and then twist it. So here, that's where I am going first. For the nut, of course, I made sure the measurement of the nut was enough on this hole for me to put the nut, and the screw, the hole of the screw is like, I don't know, 2.5-3 millimeters thick. So, well, diameter. So what I did here was like 3.2-3.3 millimeters of diameter, so that the screw doesn't have to screw through the plastic. And when it's going to save me some time, because when I put the nut in and put the screw through, I just start screwing and the nut will stay in place because of this shape. So I did it. I did that here on both, on the top and on the bottom. I'm just going to hide this one as well. And on the bottom, I did the same thing. So here, I'm just going to hide, well, I'm just gonna hide all the planes. To hide all the planes on OnShape, you just press the P for Papa, P, and it shows you all the planes you have on your sketch. Or if you press it again, it hides everything. These dotted lines, they are the guides. I made the guides, or they are the sketch. So for me to like general dimensions of the design. So I'm just going to hide that as well, so you can just click that. That'll go, and I'm just gonna hide this one as well, and these pins, just to clear what I'm going to show you. So you have again the same shape for the nuts, and the screws will go through from the top to the bottom. Of course, they are longer than I need, so I just used an angle grinder and then cut them out. For these ones, they are different screws. So let me show you what screws I used. So this screw will go through this hole. So it won't focus because it's in manual focus, but so this one is a 4.5 millimeter screw thickness, diameter. And for this one, what I did was 5.5. So I made it a little bit bigger, 1 millimeter bigger, so that if I put the screw through, it'll just go through it. I don't need to screw that up. And this little thin screw is the one that goes through these holes on the bottom and these holes on the top. This one is a 3 millimeters, as I said, but the hole is 4 millimeters diameter. So again, it helps me just to put the screw through. And if you need to make the model, the 3D printed part snug enough for you to screw any screw, just go 0.3 or 0.2 less than the size. You have to test it again. So I don't know, 1.5 years ago, I did a test where with one screw like this one, a 3 millimeter diameter screw, what I did was print a test of holes. So 3.2, 3.1, 3, 2.9, 2.8, down to 2.5, and see what hole was the best one for me to use from then on, sorry. So that gave me a 2.7 for a 3 millimeter thickness screw. I use a 2.3 hole when I need to screw this on the plastic. Of course, you have, for example, this other type of screw, which is kind of the wooden screw. This is gonna be tough for me to show you, where you have the little end of the screw like on an angle. This one is different. So again, you need to test it. Sometimes the hole is too small and you really have to force it, and it could probably break the plastic part. So just keep that in mind, test it. Another thing that I kept in mind was this hole. This hole goes all the way through to the bottom, because I need to run some cables, so I'm not going to leave the cables exposed. And so the cables will go through this hole as well, inside this hole that goes all the way up, down. And well, that's how I hide my cables. Other things to have in consideration, or that I consider when doing this module, of course, this hole is the one that goes from the top. I'm just gonna click that. So it goes from the top to the bottom, it goes inside the box, and these two little holes, they are the cables for the connector on the bottom. So I really have nothing. Well, I just have a bit of cable on the top exposed, but it's of course completely covered, so there's no electrical risk.
You have no power here.
The pins to print this box, which is interesting, you can print the box like that, or you can print the box like that. Don't go this way, of course. You can use, the rule of thumb is use the biggest surface sitting on the bed, on the printer bed. Well, there's nothing else, or there's not much to show you apart from what I've done. Just make sure whenever you're running cables, make sure you leave holes and you leave enough size, like the size of the holes are enough for you to put the cables through. So these little hole is for the cable, for the power cable. So it's not, it's clean. Last thing, these are the pins for the screws. So I did this because my plan was to print the box like that. So the base was going to be this, and it would just print the base first, and then the walls. And this angle, which is a 45-degree angle, it's perfect. The printer can live with that, so it prints perfectly. So there's no issue with the overhanging or with bridges or anything. So I did the 4 pins like that. Well, interestingly, this whole model took about 4 days worth of printing in hours, because this box, the only box, it took 15 hours to print. I'm just gonna show you a table, but it takes about 15 hours to print this box. Each bit, these bits are 10 centimeters tall. So each one took about 6 hours, and it printed 7 pieces of 6 hours. That's already 42 hours printing. The other 2 bits, which are this long one, I printed this one, which is for the top base. There was another one that is for the next bit. I'll show you in a minute. That one took about 10 hours as well. So this one was 11 hours because of this thick base. This one took about 8 hours, but I'm gonna show you a whole detailed table and images, and I'm going to show you where it failed. I had 2 or 3 printings failing. I'm going to show you that. I'm going to show you the whole list, so just stick around. I'll show you the table. So first is first, I printed in total 12 parts. This is not taking into account the parts that failed, and so it could have been probably a few more hours and of course more grams, but in total all the parts took about 107 hours printing, which is about 4.5 days worth of printing. Again, taking into account there is no I'm not counting the failed printings here. And in total, in grams of filament used for the successful parts printed, it's 647, say 650 grams. And 650 grams is not that much for the size of that lamp. It's less than 1 roll. So it's good. I mean, it really didn't take that much. Now I'm going to show you the parts that failed. So I take photos of the whole, like for every single layer, and it's funny to see this, but let me show you. So it's doing good here. This is the next layer. There is this little bit of filament here, and then it comes off. So it came off the bed because the nozzle just it just got stuck to the printing, to the part, and of course this part of the printing is wobbly, so it moves. But I reckon the issue, and it's something to take into account, this is something I just learned after 2.5 years printing. So the printer was printing perfect. Okay, so I don't know, it was probably halfway or around this area. And then I put this ant, and then I put this shark. So I think what happened was when I put these 2 models there, they pushed a little bit the bed, so it changed the level. Of course, since it shifts the level of the bed, the model will move. Even just 1/10 of a millimeter is going to be enough for this thing to fail. And so that's the first photo of the fail. Then the part when it just, I don't know how, but it was kicked out of the printer. Then like that, I don't know how. Oh yeah, I can see. So from here, since it failed, the time was 7:35 p.m. When I stopped the printer was 8:13. So from 7:37 to 8:13, it's about 36 minutes just gone away. So this is the first part, and it's funny to see all the photos one by one just going like that. But I've got the video. I've got the video here. I'm just gonna show it to you. Let me just, I'm just gonna leave it there for you to watch it. So I don't have anything on the bed, as you can see. And then I put that little octopus, nothing happened. Like I just wanted to change the things every now and then, every 1.5 hours or 2. Yeah, 1.5 hours. When I put that, I'm pretty sure that's where it failed. So bye. Anyways, that's the first failed printing, sorry. So the second one, I think this one took less time because I was looking at the printer more often. It happened the same happened. So since I think, yeah, okay. So I don't know, probably I put this little thing, which is a magnet. This is a fridge magnet I printed. If you want some of them, just contact me. But what happened was, I think that magnet changed with the time. It changed as well the level on the printer. So this one wasn't that bad because anyways, I realized about this before it went the same way than the other. So here it's been printing okay, but there is a point where the printing also comes off. 577 here. So there. So it's shifting. I don't know how it could stay so long in the probably like in the middle of the bed, but then at that point it's dead. It's just a ruined printing. So yep, it goes blah. It never goes down off the bed. It doesn't fall off, but as you can see, it's printing this gibberish on top of that piece of plastic. And well, that's it. Here, when the light turns on, that's when I realized, oh crap. Okay, anyways. Even I think on the video, you can, just gonna move it forward. Anyways, things that you learned from. So, okay, so those were the two pieces of failed printings. I'm just gonna show you all the videos. I'm going to show you all the videos, all the time lapses with all the failed printings as well, one after the other. So just enjoy it.